Hello all, here is lesson 9. We are going to be talking about functions and evaluating functions today. It says stay golden because we are so close to being finished here. So here we go. 3.1, it says 3.1, but really 3.1 doesn't matter, but we are talking about functions today. Okay. This first page, you're going to have to do a lot of pausing and playing because it's a lot of vocab here. Okay, so it says, what is a relation? Okay, a relation is pairs of inputs and outputs. So a relation, pairs of inputs and outputs. Another way to say inputs is x's. And another way to say outputs is y's. So pairs of inputs and outputs. Pairs of x's and y's. A function, okay, so the next one, what is a function? A function is a relation, okay, so it is a relation, pairs of inputs and outputs, where each input, and this is important right here, has exactly one output. So each input, each x, has exactly one y. Okay, a relation was pairs of inputs and outputs. A function is a relation where each input has exactly one output. Each x has exactly one y. Okay. Next, what is domain? Domain is the set of all possible input values, also known as x values. Okay, so the next one I'm going to unleash here all at the same time. It says, what is the range? Okay, range is the all possible output values or y values. Okay, so a relation, pairs of inputs and outputs are x's and y's. A function is a relation where each input has exactly one, and that's important, exactly one output, or each x has exactly one y. What is domain? Domain is all possible x values. What is range? Range is all possible y values or in output values. So this first page here, it says determine whether the relation is a function or not, and then explain why or why not. So I want you to pause, write down that, and then I will explain. So remember, a function is where each x has exactly one y. So what I'm going to look here is I'm going to look at my x values. Negative 2 has a y of 2. Negative 1 has a y of 2. 0 has a y of 2. 1 has a y of 2 and 1 has a y of 0 and 2 has a y of 0. Okay, what's important is each x has exactly one y. Okay, so that means the x values shouldn't repeat. Do the x values repeat? And that is no, the x values do not repeat. So is this a function? Yes, it's a function. And when asked to explain, you could say each input has exactly one output. Now you could also say each x has exactly one y, and that would be the same thing. I want you to write down B, and I want you to decide if it's a function or not a function. Okay, when I look at those x values, hopefully you decided that this is not a function because the x value of 4 is repeated. Okay, so not a function, and when you need to give an explanation, you could say the input or the x value 4 has 2 outputs or y values. All right. I'm going to give a couple more examples here. These ones aren't going to be ordered pairs. This one is broken down into a table. I want you to decide if it's a function or not a function and write out the reason why. Hopefully you decided it was not a function, and I wrote this time because the x value 0 has 2 y values. You could have used input and output instead of those this time. All right, here's the next one, and this one is in the view of a mapping. And how a mapping is described is on the left I have my input values, on the right I have my output values, and each arrow shows what the input goes to. So is this a function or not a function? Well, if you look here, each arrow is only going to one place. Each input is going to one output. It doesn't matter that they go to the same output, but each input is going to only one spot. So yes, it's a function. And you could say each x has exactly one y. Another way to tell if something is a function is the vertical line test. Alright, so again, another vocab here, but I want you to write it down and pause it as you write it. That way you don't miss anything as I'm talking. Okay, the vertical line test. If you draw a vertical line anywhere through a graph and it crosses more than once, then the graph is not a function. Okay, so if you draw a vertical line through a graph more than once, then the graph is not a function. And this one's actually pretty simple to do here. So pause, get that written down, and then play. And those are the graphs A, B, and C. Okay, so all this says here is if I draw a vertical line anywhere through the graph, so if I look there at A, I have a linear, the orange line is my function, okay? So if I look there at A, that orange line is my function. I can draw a vertical line, not quite so vertical here, but you get the gist, and it crosses one time. It doesn't matter where I draw that vertical line. On my graph, it's only going to cross one time anywhere I draw a vertical line. So is A a function? Yes, A is a function. Okay. Now B, I can draw a vertical line, and look here. It's going to cross that function twice, or not a function. It's going to cross that graph twice. So this means no, this is not a function. Now C is a little bit of a trick question, because if I draw a vertical line through a vertical line, some will say, yeah, it's a function. But it actually is not. Remember, it's touching everywhere on that vertical line. So each of these represents a point right now that it's touching. So no, this is not a function. All right, the other part of today is that we are talking about evaluating functions. So I want you to pause and write those down. I give you that, and how this is read right here. This is read f of x, okay? This right here is just saying that's the name of the function. G of x is just the name of that function. Okay, they don't mean anything specific at this point. They're just saying instead of me calling you boy, girl, I call you by your names. Okay, I call you Jenny, I call you Skylar, I call you Tanner. I don't call you boy, girl. Okay, so here we go. It says to evaluate functions. Okay, so what does that mean? So here on this first one, it says f, and remember those parentheses means of, f of 2. Well, this tells me which function I'm using. This tells me I'm going to use the f function. Okay. And this 2 tells me, well, what am I doing? Well, instead of x, what am I replacing? I'm replacing every single x value with a 2. After you input 2 everywhere x is, you're just going to simplify. So f of 2 equals, well, 3 times 2 is 6, plus 2. And then f of 2 equals 8. This is my answer. I am not solving for f, okay? I'm evaluating f of 2, not solving. So that stays as my answer. I want you to try the same thing, but notice that it says I'm using the g function this time. Okay, so I want you to pause and try the same thing. Alright, so it said we were using the g function, so that's why I made sure that I used the 2 times x minus 10. 2 times, we're replacing x with 17 minus the 10. Okay, 2 times 17 is 34, minus 10 is 24. So this right here is our final evaluating of g of 17. Alright, so next page, I want you to pause and write those down. I'm just giving you an f of x and an h of p, just something different. Again, they're just names. Okay, so write those down. The first one we're going to find is f of negative 1. So first I'm going to make sure I go into the right function. I'm doing the f of x function. And the f of x function says x squared minus x plus 10. Notice I'm just kind of leaving a shell. Everywhere there's an x, I'm putting negative 1. That includes here and here. Okay? Now to simplify f of negative 1, well, negative 1 squared is a positive 1. What happens when we have a double negative? You're right, that means we add. And then I have a plus 10. So what is the value of f of negative 1? It is 12. Okay? I want you to pause and I think, yep, I want you to do h of negative 3. There is what you should have for h of negative 3. So double check yourself. Pay attention to signs especially. That's what gets people the most on these type of questions. Alright, 7. 7 here says, and I know I'm not going in order. I don't know why I have 7. So ignore my numbers. You can just go with it today. Okay, it says, hey, let's find f of c. Okay, well I know I'm using my f of x function. So I have x squared minus x plus 10. And it tells me inside those x's, what am I putting instead? Well, I'm putting c. Well, there really isn't anything to do here. F of c is just equal to c squared minus c plus 10. I just replaced the x with a c. Last one, h of 3x. Okay, so h of 3x. I am making sure I use the h of x function, 15, or h of p function I should say, times p plus 4. Inside for p it says I'm putting 3x. Alright, so when I go to simplify this one, h of 3x equals 45x plus 4. Can I combine those together? Nope. That becomes my final answer. Okay. Hey, I have one more here for you, and that is if I'm evaluating from a graph. Okay, so this one you just kind of got to watch for just a minute or so. So if I'm evaluating from a graph, let's say that this function right here is the f of x function. And I say, hey, let's evaluate for f of, we'll say 1. Okay. Remember this 1 here is replacing the x. Okay, so what does that mean? I need to go on my graph where x equals 1. Well, here is where x equals 1. Okay, now where does it cross my function? So I'm going to kind of follow this line here. Where does it cross my function? It crosses right here at 1, 2, 3, 4, at negative 4. So f of 1 is negative 4. Okay, so another example here, let's say I told you to find f of negative 2. Okay, f of negative 2. So if I go over to my graph here, well, where is the x value equal to negative 2? Well, that's right here. So when I look here, where does it actually cross my graph of my line? Up right here. And the value of that is 2. Okay, let's say over here, this is my g of x function down here. And let's say I want to find, and I just wanted to do this one because it has a broken piece. Let's say I want to find g of negative 1. Okay, g of negative 1 on my graph, here's negative 1. Notice that when I follow it, I have 2 spots, one here and one here. Closed is what we want. Closed means it's good. So it would be 1. Thanks.